All right, so this problem here from my stat lab is one where we're going to be using the empirical rule. And so the empirical rule we're going to use anytime we are talking about bell-shaped symmetric distributions. So if they tell you that, then they're kind of giving you that hint to use the empirical rule. Other times they may just say, using the empirical rule, what percent of the data falls here. So those are kind of two things to look for. If it doesn't say that, if it says it's a skewed distribution, or maybe it doesn't say anything about the distribution, then they probably want you to use Chebyshev's rule, which is another way to look at how distributions are distributed, right? So how the data is distributed in that distribution. But since we're using the empirical rule, this is the information that we get from the empirical rule, okay? So the empirical rule tells us that always, if we have a bell-shaped distribution, 68% of our data is within one standard deviation of the mean. Okay, 95 is within 2 and 99.7 is within 3. So this part of the rule is always going to stay the same. What's going to change is what your mean and standard deviation is, right? So that's something that we'll get from the problem. So here it says we have a mean of 100 and a standard deviation of 11. Okay, so using that information, I'm going to fill in this part down here. So usually for these problems, when I'm doing the empirical rule, I will go ahead and fill in this chart and then go back to my problem and see what they're wanting me to figure out. So usually I just fill this in first, and those are going to kind of tell me the numbers that are going to be important in this problem. So we have a mean of 100, so the 100 goes right here in the middle. Then for the 68%, we add and subtract one standard deviation. So when I add 1, I'm going to be at 111. Okay, and when I subtract 1, so 100 minus 11, and we're using 11 because that's our standard deviation, I get 89. So based on the empirical rule, we are doing here IQ test scores. So we're saying 68% of people have an IQ between 89 and 111. All right, then going one more, I'm going to add a standard deviation again, and I'm going to be at 122. And then I can add another one, and I'm going to be at 133. Now we stop at 3 standard deviations because after that point there's really not much data that's more than 3 standard deviations away. We talk about how that's kind of what we might distinguish as an outlier if it's more than 3 standard deviations away. So after the 3 standard deviations, we're not going to see much of our data after that point, so we don't really worry about those numbers then. So here I'm going to subtract 11 again, and I'll be at 78, and then subtract 11, and I'll be at 67. All right, so now that I've done all that, I'm going to go back up here to my problem, and I'm going to see what they're wanting me to figure out. Okay, so it says what percentage of people have an IQ score between 89 and 111? So we look down here, 89 and 111 are both one standard deviation away, so that would just be our 68%, right? So the answer to that would be 68%. What percentage of people have an IQ score less than 89? So that means over here, or greater than 111. Okay, so if we know that 68% are inside of here, we want to know, well, how many people don't fall in there, right? So how many people have an IQ score? If they took an IQ test? Well, everybody, right? So that would be 100%. So 100% of the people are somewhere in these scores. 68 are in here, so the number of people that aren't in that range, we're just going to subtract, right? So 100 minus 68 will give us 32. So 32% of people fall outside of that one standard deviation range. And so that also we could think of as the complement rule, although you probably haven't seen that yet, but the complement rule is something that comes up in chapter 5 and 6 where we're just looking at opposites. So the opposite of being within one standard deviation is being not within one standard deviation, basically. So 32% would be the answer here. What percentage of people have an IQ score greater than 111? Okay, so for that, now we're just looking at this side, right? So how do we know just this side? Well, we have to use the fact that this is a symmetric distribution. Bell-shaped distributions are symmetric, so what's on one side is also on the other. So you have the same amount on the left as the right. So 50% is below the mean, 50% is above the mean. So if that's the case, then if in this black area here and here, I've got 32%, and I just want to know the red area, so that's just half of the black area, right? I'm just going to divide this by 2, and that will give me 16%. Okay, so that's going to be 16% is going to be the answer there. Also, 16% of people have an IQ score less than 89, so it's symmetric. That's the same either way. So these numbers here, the 16%, 32%, 68, 95, 99.7, all those percentages are going to stay the same for any bell-shaped distribution. What's going to change for each problem is what the mean and standard deviation is, okay? But the process you use is always going to stay the same. All right, so hopefully that helped. If you have any more questions about this, please let me know.